Okay, so we'll just go ahead and start by drawing this here. And then we'll go ahead and draw the lone pairs. And then there's a negative charge on this sulfur. And then this NH2 group can be broken down like so with the two lone pairs on the nitrogen. So this, because of the negative charge, that's the red flag, so this would be the base. And then this atom here would be the nucleophilic site. Or she abbreviates it, and you see. And then over here, we're going to take one of these protons. So this is the acid. And then this would be the electrophilic site. So we're going to go ahead and draw the results of taking this proton here and then breaking this bond and giving it to the nitrogen. Write this smaller. So would get now this sulfur is happy it's neutral, and we've shifted the charge over to the nitrogen because it has 1, 2, 3, 4, 5, 6, and it wants 5. So it's one more that it needs, so its final charge is negative. We've shifted the negative charge from here over to the nitrogen. And so now we want to label the conjugate acid and conjugate base. So we have the negative charge over here. So this is the conjugate base. And then this is the conjugate acid. Okay. And then looking at these, we want to go through RAO to determine strong base versus weak base. And then from there, we can look at the conjugates to determine. So the negative charge here, atom-wise, is on nitrogen and then sulfur. So if we're looking at the periodic table, they are pretty similar in electronegativity, so this doesn't help us at all. Resonance structures. The resonance structures that were drawn for this part here. So we can do a double bond and then a single bond on the oxygen and give it an extra lone pair to move the charge there. But that is also the same for the nitrogen. So they're both able to distribute the charge. So resonance doesn't play a factor because they both do it. But however, the inductive effect does play into it because we have here, we have the chlorine and then the fluorine. And fluorine is much more electronegative, so this is much more stable of a base. So this is the weak base, while this is the strong base. A strong base creates a weak acid, while the weak base conjugates with the strong acid. The weak acid would have a higher pK value. Equilibrium is shifted to the right because of the formation of the weak acid and the weak base. And then the weak acid and weak base on the right side would be present at highest concentration at equilibrium.